Okay, so now on to question number 5. Give IUPAC names for the following compounds. So the first one, the answer is already given. It looks like they just want us to answer part B. But I'll still try to talk you guys through on how to answer part A as well. So let's pretend like I didn't see what this answer was. And I'm just gonna write down the structure for part A. Got a triple bond here. Double bond here. Oh, another. Okay, so the first thing you want to do when you want to try to name compounds like this is to think of what my teacher told me was called the parent rule. So basically what the parent rule states is that the longest chain of most important things will be your parent. And also when you want to name the carbons, you want to have the lowest amount of numbers possible. So this will make more sense once I try to name this compound. Okay, so let's look at this structure. It's got 2 double bonds and a triple bond here. And I'm just going to start numbering the carbons. So 1, 2, 4, 5, 6. So we have 6 carbons in total. Then I'm also going to write down the prefixes that are involved in this question. So it's always important to memorize these prefixes, especially when you name. For 1, it's meth. 2, eth. 3, prop. 4, 5 is pent. 6 is hex. I might as well just write the other ones. 7 is hep. 8 ot. 9. 10 is dec. So these are all the different prefixes. And the first thing I like to do is to notice that this whole thing can just be like a parent. And since there are 6 carbons, I'm going to write hexa. So on carbons 1 and 3, there is a double bond. So in order to say that, I'll say 1, 3. Since there's 2 of them, I'm going to write di N. So for N, that means there's a double bond involved. And to show that I have a triple bond here, I'm going to say carbon number 5, there is a triple bond, ene. So if you're wondering where I got that N and the ene from, for alkanes, these are single bonds. Alkenes, N, are double, and alkynes are triple. And that's how you get the answer 1,3-hexa, which is our parent, di-N5-ene. So if we were to number it the other way and made this carbon 1, 2, 3, 4, 5, 6, then it would be 5,6-hexadi-N1-ine. So again, you want to have the lowest amount of numbers, so that's why I numbered this carbon as 1. So now we can go to part B with this long structure here. Just gonna start a new page. It's pretty big. So this is also question 5. Continued. You have a carbon that has these methyl groups sticking out. Have one with a single methyl group, carbon with a triple bond, carbon with 2 methyls, one that just has CH2, then ends with CH3. So again, with the parent rule, we want to find out which chain has the longest amount of all the important things. So I'm just going to circle the parent. It starts from here, and this whole thing is our parent group. Then I'm just going to circle all of the different side groups. We have 2 methyls here, there, and there. And now I'm going to number my carbons. So this is 1, 2, 4, 5, 6, 7, 8. Okay, so our parent has 8 carbons, so it will have oct. And then the first thing I'm going to do is to look at all of the different methyl groups that are here. So I'm going to do the triple bond last. But basically you want to do this in alphabetical order. And since it ends in "ine", Y is last. So I'm just going to say this will end in "4-ine". So this just shows that there is a triple bond on carbon 4. So next I'm going to write down all of the carbons that have our methyl groups on it, but I'm also going to specify which ones have 2. And in order to do that, you have to basically write the carbon number twice. So since carbon 2 has 2 methyls, I'm going to do 2, 2, 3, and then 6, 6. Penta, methyl, pitch fix. Okay, so our answer for this question is 22366 pentamethyl oct-4-ine. Let's look at the answer. So they wrote it down, 22366 pentamethyl oct-4-ine. So solution is correct.